I am Rachel. I'm the lab safety officer for the LS Core Labs. And today I'm just going to give a little sort of a overview on some of the discussions we've been having in the lab on COVID transmission, staying up to date on the research, so the things we're talking about as a group, and then also what we're thinking about with the labs, so on both a personal and professional level. So I know that it's kind of a crazy time right now. There's a lot of COVID research being conducted. It's really overwhelming. It's also amazing because there's so much coming out and we're learning so much so quickly. And then the news headlines come out all the time. I know 90% of the news is COVID related at this point. And the headlines can be really alarmist. So when you're reading the news, it can be hard to figure out what to believe or how to understand what's going on. And the recommendations are constantly changing because new information is coming out. And that's great. That's how we want to approach things as scientists. So we change our behaviors when the information changes. But that can feel like a lot to keep up with when things are moving as fast as they are. So it's kind of a unique situation right now. And so what that leads us to is, how are we making informed decisions at this point? And that is for the labs, which is our workplace and where you're going to school, but it's also for our personal lives. So we talk about this all the time in our team meetings, what's coming out in the news and in the research and what it means for us personally. So, back in March, I was sanitizing all my groceries when I went grocery shopping every single time because that seemed like the safest thing to do at that point. As more research comes out, then it's August now. I don't sanitize my groceries anymore, but I do always wear a mask when I'm in the grocery store. I limit how often I'm in there, and I'm still really careful about washing my hands after I unpack groceries, since that's just standard good practice. So we're just changing as things happen. And how do we do that? And besides just looking at the news, which I do watch and listen to the news, but I'm never really sure if everything that's coming out on the news is from people who really understand everything they're reading. Sometimes you read a news article and it seems really clear that maybe they didn't totally understand the research, or it's not being presented in a really unbiased way. So I like to go back to the original sources. So even if I read a news article, I'll look up the article that they're referencing. And this applies also, I know you guys are starting your second writing assignment this week, and we ask you to do a lit search. So I thought this was a good time to kind of also talk about how we look up literature in the scientific community. And this is SARS-CoV-2 specific, but it will also apply to a standard literature search. So hopefully it helps you a little this week too. So NCBI actually has a really great website up right now. They've set up a little portion of their website where they have a COVID section, which is wonderful. It has a bunch of resources for you. So it's constantly updated with how many nucleotide records have been entered. People who are actually doing sequencing can submit their own sequences. And then the section that we're looking at right now is this literature section. So we have articles referencing SARS-CoV-2 and COVID-19. Lit COVID is a really nice resource here because you can actually click on this and it takes you to a curated selection of literature, which is really nice. So this is constantly updated, and it has these tabs up here that you can look at. And so if you're interested in transmission, you can click on the transmission tab, and it's going to show you all of these different articles that have been selected. And you see they're super current. So a bunch of these were added on Saturday. So it's constantly being updated, and it's a great source for browsing. So if you just want to go in and browse under some of these different topics, I would highly recommend this website, which again is linked. And I'm actually going to open up the window I already had open because it's a little easier for me to look at. So Lit COVID is great for curated literature. And then PubMed is always what we recommend for general literature searches. And what they've done here that's really nice is when you click on PubMed, you can actually it takes you to the normal PubMed page, but they've pre-populated the search term for you as a starting point. So what they have here is all these different synonyms for COVID-19, which is amazing because it'll pull up basically any research that's been done on this topic. So this is where I started. And then you can always customize your search terms by adding what you're interested in looking at. So I tried a few different search terms. I always experiment to see what gets me the most results. But like you could add outbreak, you could add cluster, you could add transmission, whatever you're interested in looking at. And then normally there's a couple of options on PubMed. Normally when I'm searching PubMed, I will click on the best match. But with as much research as is coming out currently, the way I've been looking at it is I actually do go by the most recent, so that I'm seeing the most current stuff on top. And then I'll click through and choose articles. And again, this is a good example of why it's really important that we have good titles for our scientific papers. Because when you're looking, you're kind of scrolling and you're just trying to find the articles based on the title that are going to apply to you. And you can click on any of them. I have a couple open just as an example. Once you do have an article, you want to try to find full text. So you can read the abstract and see if that's helpful to you. So you know if it's something that will apply to what you're researching. But then always try to find the full text. Sometimes it's really easy. You'll have these links up top that just take you to a PDF version. They look different depending on where the text is coming from. So they can look different, but there's also the possibility that you click on something and you look up there and you're like, oh, there is no full text link. What do I do? And there's a couple other ways. Sometimes just clicking on this DOI link, which is the digital object identifier, sometimes that'll take you in and you'll see that you have a PDF access to it. If all else fails, you can Google the title and see if it pops up on Google Scholar or somewhere else where you can search it. The UCLA library is also really great with helping you get articles. So do try to find full text if it's something that you want to read, because just reading the abstract is usually not as effective as getting the entire text. So this is just a summary of sort of how I approach the PubMed lit searches. So basically you want to customize using search terms and filters, really try to get that full text access. One thing I note here is that if you are logged in through the UCLA VPN and this link takes you there, so I can post this so that you have it, that does give you more access. So sometimes if you're not logged in, you won't see all the full text access, but if you're logged in, you'll get access through our UCLA accounts. And then the other thing here is that you do, I kind of see it as an exploration. You fall into a hole, so you can check out related articles, you can click on citations, click on articles that cite the current article, and basically just follow the literature where it takes you. And that's how you get the most information. And this is the most important point is when you're reading scientific literature, regardless of what you're looking at, it's your job to stay critical. So you shouldn't be a passive reader and just accept everything that's going on. You really want to, as you're reading, think about, is this study designed well? Are there things they didn't consider? And that's just standard practice for science. So you are expected to be actively involved with your reading and thinking about it. Just because you're not an expert doesn't mean that you don't have good insights when you're reading literature. All right, so let me dive into a couple of articles that I found really interesting. And I think I have slightly more information than we have time for, so I'll try to go a little quickly, and if you guys have questions, you can ask. I like to start often with a review paper. That's something where they've searched all the available literature and looked for common themes. And so this is a nice review paper that talks about where we're seeing outbreaks, so where they're happening. They did a literature search basically, and not just through PubMed, but also through news reports. And they've been compiling this giant database of where they're seeing COVID-19 cluster outbreaks. So that's anywhere where one person infects multiple other people. And they wanted to know where that's happening, which is useful information for all of us. The cool thing is that they have this table in the actual PDF, but they also have put everything into a Google Doc, so you can download the data on your own. And one thing I really like, so this is the PDF. One thing I really like about this PDF is that it's a live document. So they have two different versions that they've updated it twice. And you can see it's actually getting peer reviewed as we go. And if you scroll down to the bottom of it, you can actually see some of the peer review comments, which I find really interesting, especially in the context of LS23L, where you're going to be doing some peer review. It's neat to see that other scientists are reading this document, and then they're giving suggestions, raising concerns and giving suggestions to the authors. And the authors actually reply to this if you go through the whole thing, and they take it into account and they make some changes to how they're analyzing the data. So it's kind of an illustration of the way we approach it, and that constructive criticism is something that's always welcome, no matter what level you're at in your career here. So I loved these tables that they had, but unfortunately they didn't give us any charts. And I actually find it pretty hard to see if you can't see the chart. So I made a really quick graph, and this is just to look at really quickly. It's not clean. You'll see there's no axis titles, and that's because the scales are totally different. So let me just explain what you're looking at really quickly. The blue here are the number of clusters observed. So these are the reported number of clusters in all these different settings. And the orange are the total number of people infected in those settings. So the sum of the people from all of the clusters. And so these are totally different scales, as you can understand, because like there may only have been 4 clusters of ship outbreaks, but obviously there are thousands of people. So the orange bars are a much higher scale, but we can't look at them together unless we do it this way. So this is a very dirty graph. It's just sort of overlaid so that I could get a sense. I sorted it by the total number of clusters. So we're seeing the most common sources of outbreaks down to the least common. Another caveat is that this data is from April. So a lot of things were shut down. So we're not seeing maybe as many school or bar outbreaks as we would have seen, because some of that stuff had already been shut down. People aren't traveling very much. So this could look really different if we updated it with the data for the whole year. But what you're seeing here that's interesting is that the largest number of outbreaks are happening in households, which makes sense because those are the people you have the closest contact with. So most people are getting infected in their own home from their relatives. However, you see that the total number of people infected in the household clusters is really small comparatively. And that again makes sense because the spread is really limited when it's just your household. So even though it's happening a lot, it doesn't impact as many people because there's, you know, maybe only 4 people that you share a house with. So there's not that far for the disease to go. Whereas this got cut off, but this is a large shared living space. So that's like a dorm, maybe a naval base, something like that. And you can see that there are a lot of clusters there, which makes sense because it's similar to a household. Everyone's living together and sharing things. But the number of infected people is much higher because there are so many more people to infect. If you're living in a dorm, you have a much bigger spread than if you're living in a household with just a couple other people. And then you can kind of see how it goes down. And some of these are interesting. Like, of course, there aren't that many cruise ship outbreaks, but when they happen, they are huge. So tons and tons of people are infected if there's a cruise ship outbreak, even though they're not that common, probably mostly because we shut down cruise ships really early in the pandemic. So this is just kind of an overview. I found it an interesting way to kind of consider where you're riskiest. But I do want to go into a couple of individual cases, which are fun. And there are a lot of cases. There's tons of case studies coming out. Some of them are research letters like this one, which is not a full study. It's more of an observational letter that got sent into a journal. So they don't have as much detail, but they're really interesting in ways to think about what we're seeing. So the first case is indoor dining. I know that indoor dining was briefly opened and then closed, so things have been going back and forth. This is a case from, I believe it was February. We'll see the dates on the next slide. But you may have seen this diagram. I think it made it into the news because it is sort of an interesting situation where you can see really clearly what's happening. So this is a restaurant in China. It's a pretty large restaurant. It's 5 floors, but this is just one tiny portion of one of the floors. So this is one area. And basically what happened is that family A had been in Wuhan. They traveled back to this city and ate out at a restaurant. And everyone felt fine. And then later that day, individual A1 started feeling sick. So they had symptoms. And then within a pretty quick amount of time, individuals started getting sick. So there were 10 people total, I believe, across these 3 families. So this is family A, who was all seated together, family B, family C. These families were also seated in the restaurant. So they're all separate groups. And what's really interesting in this case is that these families, individuals in these families did get sick. However, no one here got sick. And for context, the space between these tables is about 3 feet. So that's closer than the recommended CDC guidelines. You know, we're trying to follow a 6-foot distance now. These are all much closer together. There were a lot of people in the restaurant. So on that day that they ate here, there were 91 people eating in this restaurant. And that was it's 83 customers and 8 staff. So not everyone was eating, but it was a pretty big group of people, and yet only these 10 people got infected. And the postulated reason for this is because of the air conditioning system. So when you look at, this is a close-up of it, here's the air conditioner along this wall, there's an exhaust fan here. And so basically what they're speculating is that that flow of air that's coming back and forth, because there was no ventilation in this building, there's no windows, so no outside air is coming in, was actually causing the droplets from the infected person to move back and forth across all the tables that were in the air range. Whereas these tables, even though they were still sitting pretty close to those individuals, were out of that direct airflow, and so they didn't get infected. So it's kind of a really interesting little case study where you're thinking about what might be impacting it. And the key points that you're taking away here, or that I'm taking away here, you might see other things too, is that it's indoors and there's no ventilation. It does seem like the direction of airflow was a really big factor here. And the length of contact is likely a factor here because those tables where they were eating overlapped for approximately an hour. And you notice that only the seated diners got ill. So none of the servers that were going back and forth between different areas got sick, which to me would indicate that it is that duration of contact that probably is factoring in as well. And then it also seems like maybe surfaces are less of an issue here. They are on the 5th floor of this restaurant. So we're assuming that there's an elevator being used. There are restrooms that are shared. There's probably some kind of area where you go in and greet the host and get seated. And again, even though there were 80 other people eating that day, only those 10 people that were sitting next to each other got sick. So kind of a nice, tidy little case to look at. And then, sorry, I'm jumping through these fast so we get through them, but you can always tell me if you have any questions. Case 2 is in a call center in South Korea. So South Korea has really great contact tracing. So they have some interesting cases coming out of there. And what's interesting about this is that it was in a really dense area and it was a huge building, which is mixed use. So it's a 19-floor building. Floors 1 through 11 are commercial, and then floors 13 through 19 are residential, but they share all of the lobbies and elevators. So there's a bunch of shared spaces where residents and employees are mixing. However, employees, once they're at work, they generally stayed on their own floor. So there's no like in-building restaurant where people are congregating all together. It's just those shared spaces in the lobbies and elevators. And so what happened, and this is a little dense, but this is a timeline. So it's showing you on the bottom the dates. It's February and March, and then the number of cases that were impacted here. And so the color coding is the floor of the building where that case originated. So it started with a case on the 10th floor. A few days later, someone was sick on the 11th floor. And then you can kind of see the cases start to build. And here, this mark here is where the red arrow, the government became aware of the cases, shut down the whole building, did intensive testing. So everyone who was in the building got tested during a 3-day period so that they could figure out what was going on. And they also sent out a huge mass text message to anyone who even visited the building during this time period so that they could try to shut down the spread of the virus. People could self-isolate and see if they had symptoms. So they had a really fast, intense response to it. And what's interesting here is that the 11th floor ended up getting hit really hard. So the table at the bottom shows the total number of potentially exposed people and then the confirmed number of cases. And then second column, and only 1 person got sick on the 9th floor, which was also a call center. 2 people got sick on the 10th floor, and then 94 people got sick on the 11th floor. So it was a very different response on these different floors. No one who lived in the apartments got sick, interestingly. So this is focused just on the 11th floor, this diagram. And what is also really interesting here is that you can see that the infection spread really happened on 1/2 of the building. So even within that one floor where you're seeing shared restrooms, what looks like shared conference rooms, it's still these individuals on this one half of the floor that got really impacted. Things that would be nice to know that weren't included in the paper, again, is the air system. So we're not seeing any indicators like we did in that restaurant of where the air system is. We also don't know when these cases actually got sick. So there's no dates on here. So, because you look at this other half and you're like, it's so weird. Why didn't the virus spread through these individuals in the other half of the building if a few of them are sick? And one thing that would be interesting to know is if these people got sick right before the building was shut down. Maybe it just didn't have time to spread, but the paper doesn't include dates for the individuals, just the overall spread. So some of the key points when I'm looking at this is that, you know, the overall attack rate for the building, and the attack rate is just how many people get sick out of how many people were potentially exposed. The overall attack rate is 8.5%, but it was 43.5 on the 11th floor. And most of the infected individuals are on that one side of the floor, although we don't know the direction of the airflow. Again, we can probably assume that the length of contact is a factor, and I'm saying that because the elevators and lobbies don't seem to be a source of spread because none of the residents got sick and it didn't really go much between floors. It's also interesting that this is a call center where people are talking on their phones all day, so the amount of talking could possibly factor in. We have seen other studies where talking and singing spreads droplets more quickly than just sitting next to each other and breathing. Again, surfaces seem like they were not heavily involved in this because it didn't spread to other floors through those shared spaces. And then one thing that I was left with really wondering about this article is why didn't it spread on the 9th and 10th floors? And there's no real information about that. We don't know how the 9th and 10th floors are different. We don't know if maybe the person that got sick on the 9th floor went home, like maybe they felt more sick and they stopped coming to work. Whereas someone on the 11th floor maybe didn't feel as sick and worked all the time. So we just don't have as much information as we would like, but it would be a really interesting case, particularly if we could see how it was different on these floors, because that might give you some information about how to prevent spreading in workplaces, but we don't have that from this paper. Okay, case 3, this is a hospital. And I find this really interesting. This is a tiny case. So it's just a research letter. It's not a giant study. And it's just looking at a couple of individuals. But I think it's really interesting, especially for our course, because it actually uses the genome sequence to determine the source of the transmission. So the timeline here is that there's a healthcare worker who comes in contact with 2 confirmed COVID patients in a hospital setting. The healthcare worker is wearing proper PPE. So that is a mask, a face shield, and gloves. That's what the hospital that he's in requires. However, 4 days later, they come down with, or they become symptomatic, and then 4 days later, they test positive. So the top line here is the patient 1, the second line is patient 2, and the third line is the healthcare worker. The dates are along the bottom, so we're seeing the progression of those clinical cases, and dotted is healthy, blue is symptomatic, and the red circles are when you get a positive PCR. So confirmed case. The healthcare worker encountered these patients on these couple of days, and then shortly after that becomes symptomatic, tests, and gets a positive PCR. And the hospital is interested in knowing if the healthcare worker contacted COVID at the hospital, because that would be an indicator that the PPE the hospital is recommending is not effective. If their workers are getting sick despite wearing PPE, they probably need to reinvestigate how they're protecting their workers. So they go on in and start doing interviews, and what they find is interesting. They find that the healthcare worker actually has a family member who was symptomatic 8 days before, but wasn't tested initially because tests were really limited. This is taking place in Chicago. I don't remember the date, but it's early enough in the pandemic that they haven't, oh, here it is, it's on the bottom, of course. So it's in March and April, so it's pretty early on still. So they didn't have enough tests, but they do go in and test that family member now, and sure enough, they test positive. So now we have a person who is exposed to 3 separate cases of COVID in 2 different settings. And we want to know which exposure caused that person's infection. And because COVID mutates pretty quickly, you can actually do this easily by looking at the sequence. So they sequenced the isolated virus from each of these patients and then lined them up and compared it. And we're going to talk about this a little more in LS23L later. But what they found was when they lined up these sequences, the healthcare worker and their family member had identical sequences. So every single mutation is the same on their sequences. If you look at patient 1, they had several sequences at different positions that are different, so their sequence varies. And then patient 2 has yet another variation. So these are 3 distinct lines of the virus, and it makes it really clear that the most likely transmission route is that the healthcare worker did in fact contact this virus from their household and not from their workplace. And this supports the previous studies that show that the attack rate, your likelihood of getting sick, is much higher among your family members versus your versus anywhere else that you are. And it also provides some reassurance to the hospital that the PPE they were using didn't fail the healthcare worker. And on a broader level, it indicates that if we were doing more testing at that point in time, we could help reduce the transmission. So if that family member had been able to get tested quickly when they were feeling sick in the beginning, they maybe could have isolated themselves. The healthcare worker could definitely have isolated themselves, and it would have helped contain that infection. All right, I think I have time for this one. I'm going a little quickly to make sure, because I had a really hard time narrowing down the cases. There's like 5 others that I rejected, but would have been interesting too. So this case is for family gatherings, and I picked this one because I know that we are all getting really antsy. I know that I am. Some of us haven't seen our families in a long time, and we're starting to try to figure out what our lives look like and what it is safe for us to do and how we can do things. And unfortunately, it still does seem true that family gatherings are a really risky thing to do. So this is a case in Chicago where there were 2 family gatherings in a short period of time that ended up leading to quite a bit of spread. So this was early in the pandemic. It was February and March. We didn't have masking in place at this point. So this played out a little differently than it might have if masks had already been required. So this is the diagram of the clinical progression of each of these cases. There's a lot to look at, but basically the solid boxes are individuals who have lab confirmed COVID. So they got a positive PCR test. The dashed lines are individuals who have likely cases of COVID. So they experienced symptoms, they were exposed to a positive person. The assumption is that they did indeed have COVID, but it was not tested and confirmed. So we can't say for sure that that happened. And then what happened here is individual A 1.1, it was having mild respiratory symptoms. And they don't specify what that is, but I'm assuming, maybe a little bit of coughing or some congestion. But basically they felt fine. They were able to be up and about. They didn't, they weren't feeling so sick that they felt like they needed to stay home. Just like us in pre-COVID era, maybe you go to work with a slight cold or something like that. And there was a close friend who died, not of COVID-related causes, just a funeral. And so individual A 1.1 traveled and went to that person's funeral. And at that funeral, they came in contact over the course of 2 days. They were really close friends with this family. So they had a meal with the family the night before the funeral and hung out with them for about 3 hours, and then also went to the funeral and the wake after the funeral. So they had sustained contact, multiple hours, and shared food with several individuals from family B. And what happened is that there are 3 cases that we know of where individuals from family B became sick afterwards. So this is happening right here. It's just a few days after the exposure. However, individual A 1.1 is still feeling okay, still experiencing symptoms, but not very sick. And so they go ahead and they travel to a birthday party for their family. So they're going to a family member's birthday. It's about a 3-hour party. Everyone is sharing food and hanging out. And what happens is these individuals get sick at that party. So 3 of them are confirmed cases. 4 of them are suspected based on symptoms. And the clinical progression of this is really sad, but what it does is it shows you how quickly this can spread from one person who's feeling pretty fine, just mild symptoms. And so individuals in family B were sick. These 2 were fine and they recovered. Individual B 2.1 actually did end up hospitalized. That's what the gray dot is. So on day 12, They were hospitalized. During that time, they actually got another family member sick because individual B3.1 visited them in the hospital and got COVID, suspected. And then they stayed in the hospital. At this point, Illinois is starting to shut down, but it's too late for this family. So they stay in the hospital, and on a day 28, this individual sadly does pass away. And then we see a similar sort of source of spread here with the family A. So family member A 2.1 gets really sick. They have, I think individual C 3.1 is actually is a healthcare provider, someone who came into the house and helped, but it could be another family. And then they have some household contacts. These people get sick. Individual A 2.1 ends up hospitalized and does pass away. Individual A 2.2 has a similar progression. These individuals are suspected cases. They were symptomatic and not feeling well, but they didn't get tested. And they went about their daily lives. A few days later, they went to a church service where they were in church for about 90 minutes, sitting in a pew next to individual D, so someone from a totally different family. This person did get sick and had a confirmed case. So it's just a quick illustration of how one person who is not feeling that sick can really spread the disease pretty quickly. And that is likely the cause for a lot of disease spread, people who feel fine. So it's not necessarily asymptomatic people, although that does happen, and the rates of asymptomatic people are we're still figuring that out, but even people who are just handling the disease better. And it also indicates that gatherings with friends and relatives can be really risky. The hypothesis here is that you have more close contact. Your guard is a little more down when you're with your friends and family. So you tend to talk more, you touch each other more, and you're in each other's space a little more than you would be with a stranger. So it does involve a lot more risk. All right, so those are the case studies I picked. And then these are some of the key points that I wanted to discuss. They are not all drawn from these case studies. As I mentioned, I have a lot more that I didn't share with you because we don't have time for it. So this is kind of where I am on COVID transmission at this point and how I'm managing my own life and what we're thinking about with the lab reopening. So what we take away from the current research is that the duration of contact does really seem to make a difference. So longer encounters, especially those that are an hour or more, are going to be riskier. The nature of contact matters. So if you're talking to someone, if you're singing, if you're laughing, the risk of droplet spread is much higher. I didn't share it, but there's actually a couple of cases that show directly that singing, there's the choir practice. There's also like a karaoke evening with coworkers that was shown to spread a lot of COVID. So singing does seem to project those droplets further and make it riskier. And then the setting matters. So when you're indoor with low ventilation, the way we saw in that restaurant or in the call center, the risk of you spreading the illness is much higher. All of these seem to be contributing to indication that surface transmission is less likely. It's possible that we just aren't seeing it because people who maybe are in contact with those surfaces are also having face-to-face contact with people who are sick, so maybe it's just being obscured that way. But I would think that if surface transmission was really common or risky, we would be seeing clusters coming out of places like grocery stores where people are touching things and then it's spreading. And so far, we really aren't seeing any of those reported. They might just be harder to trace back, but I still think we would be seeing some if it was happening. And so far, I couldn't find anything that looked like that, where surface transmission was the source for people. And the final thing, which I didn't really go into here, but there is a lot of research on this, is that PPE really helps. There's even new research coming out that indicates that if you are wearing a mask, you tend to get a lower viral exposure. Even if you still get sick, the chances are that you get less sick. And they're thinking that the rate of asymptomatic people is actually going way up in countries where people are wearing masks regularly. So they're getting less sick, which maybe is still providing you with immunity, but you're less likely to get really ill. So wearing a mask does really help. So we encourage everyone to wear them. I'm definitely wearing a mask anytime I'm going out. And again, practicing good hygiene. And for the labs, what this tells us is that we need to think about how long we have people in the lab rooms. what we're doing in terms of activities, how we're managing the space, what our ventilation system looks like. And then again, if it was back in March, we would maybe be throwing a bunch of money at disinfecting all our surfaces all the time, constantly. And it's August now, and we're thinking maybe what you want to spend money on is HEPA filters for your ventilation system or plexiglass barriers so that people aren't transmitting droplets directly to each other. So we're just going to keep up to date on that research. We're actively looking at our reopening plan, and we're going to make sure that it's informed by the best possible current research. It'll probably change several times as things happen. But it is, even though it can feel really stressful, this is also a really interesting time to be involved in science. So I hope that you feel empowered, even though you aren't maybe an expert in this field. I mean, I'm not an epidemiologist, but reading the literature and getting your own takeaway can be really important. Even if you don't necessarily understand all of the stats or some of the terms that are in the papers, you can still read them and try to think critically about them and try to develop a better understanding of what's going on in the world. So that's it for my PowerPoint. I think we're right at time, basically, but if there are questions, I'm happy to try to answer them.
There was a really good question in the chat, Rachel.
Okay, you really can't see the chat when you're talking.
Yeah. Do you want me to read it, or do you want to read it?
Let me take a look and then see what it is. Okay. So the question is how long the peer review and approval process takes place and if a paper was published a few days ago. This is a great question. And the thing that we're seeing in the literature right now, because it's coming out so fast, it has not all been peer reviewed. So NIH is actually publishing a lot of preprints, which is a little uncommon, I think. We don't normally see as many. I think normally they take longer because, yes, the peer review process takes a while. It's still moving pretty quickly. So you're seeing articles that are only maybe a month old that have been through the peer review process. But you are also seeing preprints. They're usually really clearly labeled as preprints. And that is basically, I would consider it like a draft of a paper. So it's a paper that has gone through all the initial stages. It's been accepted to a journal, but it hasn't been through that final stage of peer review where it gets the input and then maybe makes modifications. So yes, it's something to keep in mind that papers that you're seeing online right now are not all peer reviewed. And it's another reason why you do want to be critical when you're reading. You don't want to just blindly accept those texts, even though they're coming from a good source. It doesn't mean anyone's trying to mislead you. It just means that stuff is coming out faster than it's really getting vetted. Okay.
Great, wonderful. Okay, so that was a primer to look at COVID-19 sequences, and that's what we're going to be looking at next week, and also what your video PowerPoint presentation at the end of the session will be about. So that was, I hope, very useful. Once you get your project, how you can look into research and maybe try to read, some of the papers. Well, thank you, Rachel. And I'm gonna, if there's no more questions, I'm gonna stop recording and see you all next week. Bye.